Hey everybody, welcome to the lightning talks today. Hope you're finding some useful information. My name is Jeremy. I work at Microsoft on the Copacetic project. We're going to talk to you a little bit about what the project is and maybe get some interest for you. So just as a quick show of hands, who hates CVEs in container images? All right. So Copacetic is a project in the CNCF sandbox that is intended to directly patch images to alleviate container vulnerabilities. It's a CLI that's written in Go, and it's based off of Buildkit, which is the default builder for Docker. So if you're using a newer version of Docker and you say Docker build, in essence, that's using Buildkit behind the scenes. There's a whole bunch of libraries that come along with that help you to assemble, do operations on top of container images. And Copa uses this to help us replace things in the container and generate a new container image without having to go through the full build process again. And it does this by taking in a container vulnerability scan report. By default, it takes in Trivy. Trivy is another popular project in the ecosystem. And by default, it will take in the Trivy report and look for the OS vulnerabilities. So things like maybe you have curl installed in the application or in your container image, or something like OpenSSL. Those are things that commonly get CVEs and might show up in a scan. Copa will take that scan and identify which things are vulnerable and then build off of there. That component is pluggable, so you can replace it with another tool of your choice. But by default, it uses Trivy. And how this works is you take your base image, so we can call this the MacGuffin image. It's got an application layer, a framework layer, maybe some other layers that have all the OS vulnerability, or sorry, OS packages installed inside of them. It's run through a tool like Trivy. That report is then passed into Copa, the CLI. You run it by running Copa with the right arguments. It analyzes that scan report, and then it looks through the container image, determines what things need to be updated, and then it generates a patch layer, which is really just a diff between the things that were installed and the image that was there before, and it generates a brand new layer that gets appended on top of the image. So you're able to take upstream things that you maybe don't build yourself. You can take things like distroless containers that don't have package managers inside of them by default, and through the tooling image that it brings along, you're able to actually fix the vulnerabilities that are inside of that. OpenSSL libs are a pretty common one. We use this quite often in the past to patch things like Qproxy, which is a distroless-ish image, but often had OpenSSL libraries that were vulnerable. Once that is updated, you're able to push that to your container registry and use it basically like you would the original image. Recently, there have been a couple of features that are pretty cool that have been added to Copa. Before, you had to essentially run it on whatever target architecture you were looking for. So if you were trying to patch an ARM64 image, you had to patch it on an ARM64 machine. Now it actually supports doing multiple platforms. It'll do that for you. It works on all OCI media types now instead of just Docker images, which is what it was built to use originally. And it supports running inside of Podman. And I think most interestingly, it's starting to get features that allow it to patch things beyond OS vulnerabilities. So historically, what Copa really was helping us with was fixing things like OpenSSL libs. But things like Python and Node.js, it can actually now look through those applications, find vulnerabilities in the application dependencies themselves, and start to replace them. And additionally, there is an MCP server for all of your fun AI initiatives. Coming soon, we've got a couple of other good features. There will be bulk image patching, so instead of having to run once per image, you'll be able to specify a batch, and it will go through and update them all for you. And instead of running Copa directly as a CLI, we are working on a Buildkit front end. Buildkit front end is just something that allows you to use any tool that can use Buildkit to execute that functionality. So by default, if you're using Docker build again, there's an implicit Buildkit front end defined at the top of your Docker file, which is the Buildkit front end. So you'd be able to use something like Docker or buildctl to invoke all of the Copa functionality. If you're interested in getting into Copa, there's a QR code here that'll take you to the Copa repo on GitHub, and you can check it out. We have weekly community meetings Wednesdays at 6:30 p.m. Eastern time. There's also a GitHub action for using Copa inside of build workflows inside of GitHub, a Docker extension, and a plugin repo for building your own scanner plugins. Thanks.